It's a beautiful day in the neighborhood. Oh, hello there. I didn't see you. What a beautiful day. The weather is nice. The birds are chirping. And it's just a lovely day. Knock, knock, knock. Heidi ho, Miss Megan.
Heidi ho.
We're studying about the mole today. A mole is a term in chemistry we use quite a bit, actually. There are three main definitions of moles we will study today. And we're also going to go deeper into exactly what the mole is used for. A mole. A mole is a number. What is its number?
6.02 times 10 to the 23 particles.
You're exactly right, Miss Megan. This number is used just like a dozen is used. Molar mass is the mass of one mole of a substance. We're going to do some examples now, kids.
We take a compound right here, and then in each element within the compound, we find the atomic mass on the periodic table, and then we add them up to find the total molar mass, which is grams per mole. So in this instance, for carbon dioxide, we have one carbon atom, which is 12.011 grams, and then we have two oxygen atoms, and which are each 15.99 grams, and so both of those together plus the carbon equals 44.009 grams per mole, which is the molar mass.
Okay, 22.4 liters equals 1 mole. So when you're trying to convert moles to liters, you take 2.05, which is an example of moles, multiply it by 22.4 liters over 1 mole. And when you multiply 2.05 and 22.4, it equals 45.92 liters.
Percent composition, to find it, you find the percent composition by finding the mass of the element divided by the total mass of the compound. This decimal multiplied by 100 is the percent composition. So, for an example problem, to find the percent composition of magnesium oxide, you do the molecular mass of magnesium plus the molecular mass of oxygen, which equals 40 grams, rounded. And then to find the percent of magnesium and oxygen, you do 24 over 40 because it's part over whole, and then that decimal times 100 equals 60%. And then you do the same thing for oxygen to get 40%.
The definition of a percent yield is the ratio of actual yield to theoretical yield. The formula is percent yield equals actual yield from experiment over theoretical yield from calculations times 100. The first thing we do is we write out the reaction, and then you balance it. You have 0.5 multiplied by is the amount given, and then you have 0.455 grams, which is the amount produced. So in order for you to find the theoretical, say you take 0.5, and then you'll take the molar mass of silver nitrate. All the calculations on the bottom of the paper then equal to 0.488. And so, but you only produce 0.455. So what you do is you take 0.455 divided by 0.488 grams times 100 equals 93.2% yield.
For empirical formula is the simplest positive integer ratio of atoms of each element present in the compound. This is contrasting to molecular formula, which is where it identifies the number of each type of atom in a molecule. Molecular formula is more specific, and empirical formula is more basic.
Here we have a balanced equation, and in order to balance and do the reactions right here, we need to make sure we have a balanced equation. We're going to calculate the molar masses of the compounds that we're interested in, and then we're going to determine the mole-to-mole ratio for the coefficients in the balance equation. Then we're going to actually solve the problem. So we do have our total mass that is given. This number will always be given. It's 152.6 grams of CO. Then this is the molar mass of carbon monoxide, and that cancels out. Next, we have the multiple ratio of the balanced equation. Ladies and gentlemen, this is very important to make sure the equation is balanced. Once we have that, that cancels out the carbon monoxides, and we're left with the moles of iron. And the moles of iron cancel out to get grams of iron, and we're actually left with 18 grams of iron. This is reactive stoichiometry. It's a balanced equation. Again, make sure that you have a balanced equation. You calculate the molar masses, determine the mole-to-mole ratio, and finally solve the problem. Keep it. Make sure of your units. You can see Mr. Mole has his balanced equation. It's written out, and he is going to start with the 2 grams of ammonia, and he's going to use the molar mass of ammonia, and he's going to use the mole-to-mole ratio, and finally he is then going to use the molar mass of NO to get the total grams per NO, and then he's going to do the same with the 4.00 grams of oxygen he has. We're going to do that. He's going to get 3.00 grams of NO. If you really want to look at this a little further, please visit our website, and Mr. Mole will gladly explain it a little bit more. Kids, I do hope that you have learned something today. Mr. Mole is a great teacher, Miss Megan is a great teacher, and so is Miss Gabby. I'll just let myself go. Here's my hat. We're off. It's a beautiful day in the neighborhood. It's a beautiful day in the neighborhood. Connor, man,